Monitoring loads and wear of machine components has always been a challenging task in manufacturing. Under the EU-funded program Change the Twin, Salvagnini Maschinenbau, the Linz Center of Mechatronics and the University of Applied Science, Upper Austria, have developed a digital twin for predictive maintenance. The developed solution allows the monitoring of wear and loads on panel benders to predict and prevent potential issues before they occur. We are here at Salvagnini Maschinenbau, a research and development center for bending technology and the worldwide biggest plant for panel benders. Sheet metal bending is the process of shaping flat metal sheets into a desired shape or form by applying force. It is a common process in the metal fabrication industry and is used to produce a wide range of products, from doors and metal furniture to agricultural equipment and automotive parts. Salvagnini panel benders allow to rapidly complete a part that requires bends with variable angles and accurate radius forming hemming or offset bends. To ensure precise and accurate bending results, maintaining machine component health is essential. Therefore, the Salvagnini Link system allows service engineers to remotely access and analyze machine data from the field. With the predictive project, we went one step further. We created a digital twin for predictive maintenance to monitor and compute the remaining useful lifetime of machine components, like the bearings, the actuators, and the rotator clamp. The digital twin is based on simulation results and can compute unmeasurable quantities, like for instance the evolution of contact pressure in the bearings for every single bend during production. These virtual sensing capabilities, combined with live sensor measurements, allows to virtually track the degradation of different parts and compute their remaining useful lifetime. The information on component health is automatically computed and displayed to the service engineers in Power BI. It is also possible to investigate the degradation behavior over time. Implemented in the Salvagnini cloud, the predictive solution enables service technicians to identify potential problems before they become critical and schedule maintenance accordingly.